This is practice quiz 3 for quiz 5 in the second trimester of Algebra 2. So first page on this, you want to look to cancel any factors, and then you're good to go. So -1. So any factor that's left on the bottom. Horizontal asymptote. So again, there's going to be none. Why? Because the power, so if we multiplied all this out, the power in the numerator is greater by 1. So whenever it's greater, you're done. There's no horizontal asymptote. Okay, if it was equal, if the powers were equal, we'd take the ratio of the coefficients. And then if it was greater in the denominator, the highest power, then it would be automatically 0, the x-axis. X equals 4 on this one. So wherever you cancel factors there, find the x-intercepts. So these two would get set equal to 0. Again, you should be doing this mentally. You should not be writing this down. You should be writing down the answers only. Find the y-intercept. So you're going to go in and put in 0 for x everywhere. So it kind of just leaves these end values like this. So positive 36 over -4. And if you're not sure, put this original expression into your calculator. You got to put the whole thing in. Don't put the canceled version in. Is there an oblique asymptote? The answer is yes. Why? Because the power is 1 higher and we still have an algebraic term left in the denominator. True or false? The domain is all reals except 1. That's false. The domain is all reals except -1. Okay, so you're taking except -1 and 4, actually, both of those. Okay, so make sure you're going back to do those correctly. All right, problem 8. Again, going pretty quickly through this, we need to factor. So x minus 5 times x plus 1 over x plus 2 times x plus 1. So the x plus 1's drop, meaning there's going to be a point discontinuity. All right, so vertical asymptotes at -2. Horizontal asymptotes, yes. Okay, look at the ratio of the highest powers. 1, meaning that there are no oblique asymptotes. They eliminate each other. Okay, point discontinuities, yes, at -1. And then that goes into what's left over. So -6 over 1, which is -6. So -1, -6. Find the y-intercept. So you can go to the original or the reduced. So it doesn't matter on the y-intercept. I always go to the reduced or try to. -2.5. X-intercepts, you got to go to the reduced. You take the numerator equal to 0. They should be doing that mentally also. Okay, so there is all of our data that we need. So vertical through -2. Horizontal through 1. So you just go down the line and you put all these features on the graph. Point at -1, -6. Right here. X-intercept at 5. Y-intercept at -2.5. And then this other branch is up here. So again, you have to have all of these features on the graph. Domain, okay, we need to strike out vertical asymptotes and the x value. In the range, horizontal asymptotes and the y value of the point discontinuity. Again, those that has to appear down there. Okay, over and over and over, you get the feel of this. hopefully, make sure you get the factoring right in the beginning or everything will be off. And generally, I set the factoring up so that there will be canceling. So make that an expectation. So this will be 1 over x plus 4. Now I know with this, there's not going to be an x-intercept because there's no x terms left in the numerator. So you can immediately, mark that. So horizontal asymptote. So again, we're looking at this. So it's automatically 0 because the power is higher in the denominator. And that's the x-axis. So it's an automatic answer. Find all point discontinuities. So at -3, and then the y is going to be 1 over -3 plus 4 is 1. So -3, 1. Y-intercept, that's when x equals 0. Again, you can go to either one. It doesn't matter. And we get 1/4. And so no oblique. And so we should be relating these two. Once you say you have a horizontal asymptote, that immediately eliminates the possibility for an oblique. All right, so -4. And -3, 1. No x-intercept. The y-intercept is 0.25. Okay, so that means here we're going to look like this. How do I know? Because I know because of where all these features are, and it has to hug these asymptotes. It has to get really close. So in my mind, I start sketching it. I got to go through these two and hug. That means I got to be down here. You can look. So how do you know it's not up there? You can look. I encourage you to look at the graph, and that will help, or at the table, either way. So x is an element of the reals. X does not equal -4. And y does not equal 0, and y does not equal 1. Okay, so again, we're striking out these things. This is the vertical and horizontal asymptote. This is the point discontinuity that we're striking out of the domain and range. Okay, same idea on this DJ problem. So we have $600 total cost, so 4x plus 600, $4 for each ticket over x. So find the horizontal asymptote. It is $4. Again, the ratio of those highest powered terms, it represents the lowest possible price. You actually don't get there. It's like the lowest bound. We have 450 students, so 450 will go in. And then you come up with the Y value, and that is $5.33. So you can see it's getting closer to the $5 the more students attend. Okay, and then on the back, you should do these. This is an easy A, and I'm intending your spiral to be a pretty easy A, but you got to put the work in. So 2 to 1, here we go. This will be 12, this will be 6 times the square root of 3. Here's the other 30, 60, 90. So this would be 7 and 14. 45, 45, 90. 5 times the square root of 2. And these are each 2. And that is the third practice quiz for quiz 5 in the second try.